expensive. They also produce a lot more watts per square foot. Let me give you guys a couple examples. 2-3 years ago, if you asked what the pre-incentive cost of a solar electric system, you'd be looking at about $10 a watt. At the start of '09, the cost was $8 a watt. By the summer of '09, $7 a watt was very common. By the end of '09, for large systems, we were seeing quotes coming back from the field, $625, $650 a watt. So you're a huge reduction in cost. Now, at the same time, the output on a per square foot basis, your watts per square foot, also increased dramatically. 2-3 years ago, if you were going to be putting in a 10 kilowatt system, the size to do an average house or a fairly large house, you would need 1,000 square feet of either south-facing roof or a ground mount system. Now, that same production can be done in 600 square feet. So not only have the systems become less expensive, they've gotten smaller, therefore much easier to integrate into the building. Okay, that's factor number one, is the cost has come way down. Plus, at the end of '08, start of '09, we've always had a tax credit for solar systems. It's 30% of the cost of the system, but it used to be capped at $2,000. Now there's no longer a cap. So basically, whatever the cost of the system is, you get about 30% off of that in terms of a federal income tax credit. Thirdly, now this is something that's happened over a long period of time, but it's really kind of snuck up on me, at any rate, lately. Homes have gotten significantly more efficient in the last few years. Insulation's better, windows are better, higher HVAC, much more efficient lights and appliances. And all those things have come together to make producing enough energy for a house easier because we're not using as much. Okay, and the last thing, and this is something that's just now happened at the very end of '09, is the introduction of unbelievably efficient air-to-water heat pumps. These are devices that use ambient air temperature to create warm water for domestic, warm water for space heating, either through floor heating or through fan coils and forced air, and chilled water for air conditioning. And these units are just coming on the market in the United States. They're very popular overseas, and like I said, they're very efficient. So the convergence of those factors give us the following results. Building a net zero energy house is affordable, practical today. We're seeing paybacks typically between 5 and 7 years. If you would have asked me the same question in '06, '05, we would have said 20-year payback. Now the paybacks are, again, like somewhere between 5 and 7 years. That gives a return on investment to the homeowner, the home builder, of somewhere between 15 to 20%, which, who wouldn't take that these days? Like I mentioned earlier, the systems are much easier to integrate into the building because they're smaller, and there's many products on the market that have solar electric cells built into the building material, be it the roofing material or whatever. And the best part of all is that these systems are low maintenance and fairly simple. Okay, there's 4 parts to a net zero energy house. The first part is the easiest, and you're already doing it, and it doesn't affect the design of the house, doesn't affect the lifestyle of the occupants in any way. Just the basic reduction of how much energy homes are using. And net zero energy is a balance between reduction and production. The more we reduce, the less we have to produce. But the insulation, like I mentioned, the insulation's better. The windows are significantly better. HVAC systems, not only they're different types, but they're also a lot more efficient. And there's nothing more dynamic right now in home construction than the lighting business and how efficient the new lights coming out are. Appliances the same way. And verification. I've been doing energy calc since 1982, and for the most part, there's been absolutely no verification or even, be it plan checks, be it field inspections. They've been ignored since the energy code started back then. Nowadays, especially with the new energy code that just went into effect, you're going to see, verification of insulation quality, verification of infiltration control, verification of duct loss. Maybe not on every new house, but most every new house. The new energy code is tough to comply with. Okay, so that's on the reduction side, and those things are already being done. Like I say, they don't really add much cost to the building because they're already being done. And again, they don't affect the design. On the production side, we have 3 basic types of solar systems. We have your grid-type solar electric systems. We have a system called PVT, which stands for photovoltaic and thermal. It's a combination system. And then you have your kind of old-fashioned standard solar thermal systems. The first solar thermal system I installed was in 1979, and they really haven't changed much. So we talk a little bit about that. So we got reduction, we got production. And then we calculate. And when we calculate, how much energy a building's going to use, like with the energy code, it's everything with inside, it's energy within inside the walls of the building. It's within inside the heated space. We look at net zero energy differently. We look at it for how much energy is that property going to use. Not only the lights and appliances, the domestic hot water, space heating and air conditioning, but also hobby use, be it computers, be it electric music instruments, be it stuff outside, outdoor lighting, well pumps, swimming pool pumps, you name it. We calculate it, we factor it in to solve for exactly how many kilowatt hours you need on an annual basis. And then the last part is the design of the solar system to produce the amount of energy we need. Okay, why is all this important? I mean, I think it's important because it's the sort of thing that we have clients asking for this every day. But for the design professionals, you need to understand by 2016, half of all new homes in California have to be net zero energy. By 2020, every house in California, unless there's a building in the way, a mountain in the way, or a bunch of trees in the way, have to be net zero energy. Also, right now there are 9 million existing owner-occupied single-family dwellings in California. Later in 2010, somewhere around the summer, every one of those homeowners will have an option to take out what's known as an AB 811 loan. This is a financing package to allow their home to be, it's a very attractive financing package, to allow their home to be improved energy-wise. Simple things like adding insulation all the way to converting it to being net zero energy. So those are some of the factors that are coming. And then you add that to the fact we have, for the most part, a very mild climate. We have abundant sunshine. And by the end of 2010, we're supposed to have what's known as feed-in tariffs. This is where if we overshoot and we produce more solar energy than we're consuming, we actually get paid for it. But that's still to be worked out. Okay, the problem with being net zero energy, and the problem and the challenge to it, is the fact that in California we pay unbelievably high rates for electricity. One of the reasons the payback for solar electric systems is so good is the fact that the energy that it's replacing is so expensive. A quick anecdote. In the world, Japan is the leading country this year, or in 2009, for putting in grid-tie solar electric systems. Germany is number 2. If the PG&E territory was a country, we'd be the third largest, or we would be installing the third most grid-tie solar electric systems than any other place on the planet. Part of it is because of the rates you see in front of you. The way our electric rates work throughout California, but, well, not all. There's a few smaller spots that aren't quite this bad. But these are PG&E's rates as of the first of the year. The first thing you notice is there are 5 tiers. And the more you use, the more you pay. At the lower tier, which is basically if you have like a studio apartment, you're apt to use somewhere close to 250 kilowatt hours a month, and you pay 12 cents a kilowatt, which isn't too bad. The average is somewhere around 8 cents a kilowatt. The problem in California is, okay, we start off at 12, so it's already quite a bit more, but the more you use, the more you pay.